recognition for restaurants, a system for improving customer service in the restaurant industry. This is our project's outline. I'm Timai Nuzo, the team leader and electrical engineer who is mostly working on hardware as well as some software aspects of the project.
My name's Owen McGee. I'm a computer engineer that was the software lead and worked on any software associated with this project.
My name is Ines Sokolov. I'm an electrical engineer working on the hardware needed for the project along with helping with software. My strong suits include electronic circuits and math. For our project summary, we developed our own facial recognition method using a Raspberry Pi board in which we run through a database in order for the customer's information and past orders to be processed and saved. This information is then transferred to a point of sale system and that we'll use for restaurant transactions. This information can then be displayed for restaurant staff to see and take into account different orders. The customer will then have an option to either reorder something from the past or make a completely new order, and this will provide the customer with a more pleasant dining experience while avoiding wait times. This will also help restaurants maximize their time efficiency so that they know a certain individual comes in at the same time, that orders the same thing every time. They might have certain things ready. This will also help on busy nights for restaurants to keep track of information and to be able to keep track of the restaurant statistics as well.
For our project selection, during our early stages of research, we found out that there is multiple system requirements that ranged in importance that included security, algorithm efficiency, cost, and our sensor. Obviously, cost is a huge priority. We're designing this for kind of smaller restaurants, family-owned restaurants that don't have the budget that a chain might have. Obviously, for increased image quality, we would be able to get a better sensor, better hardware, but we didn't have the budget for that. Cloud storage was also an idea we looked into initially, but that was a lot more short-term cost that we just didn't have at the time.
Next one. For our engineering requirements, we had performance where a system should record and give accurate information and relay information in milliseconds. Our security, the application should be secure so that no one else has any access to it except for the restaurant and the individual. Also accuracy, where measurements must be precise and accurate every time the face is recognized. Maintenance, where it should be easy to set up and require a minimal amount of maintenance. The database must contain a customer's past order history, including food, drink, time of purchase, and their time spent in the restaurant, and how much their bill comes to. For our marketing requirements, we have that it must require fast customer throughput. It has to be easy to install, easy to use, have a low cost, ensure security and efficiency. For the engineering trade-off matrix, you can see here how the engineering and marketing requirements kind of go hand in hand. For example, the higher the accuracy and the higher the security, that will cause a more positive correlation. And then if you want a higher accuracy with a lower cost, this will sort of have a strong negative correlation, because in order to have higher accuracy, usually you need more costly and better technology.
As for the analytical hierarchy process, the two main things that are stressed in this project are cost and algorithm efficiency. We want it to be affordable so any restaurant would be able to purchase and maintain this product. And we need it to be efficient so that it can be more helpful to the customers instead of a hindrance that takes up their time.
For the system description, first we start off with the customer, which consists of the facial recognition aspect. And then that's moved to the database, which processes the user's information. And then it's ultimately moved to the restaurant owner or the POS system, where it displays the user's information.
This is our related theory. The facial recognition algorithm used was the horror cascade detection. The purpose of horror cascade is to be used for identification of people and objects in videos and images. For this algorithm to work, there needs to be a large pool of positive and negative images in order to train the classifier. And the classifier extracts features through finding similar pixels in regions of squares and rectangles. And horror classification also involves features passing through rejection cascades in order from least complex to most complex. The reason why this is the case is so that it can help reject features at a quicker pace. As can be seen here, this is the horror wavelet that's used, and this is the conditions for the horror wavelet. And this is the equation that's used for helping to create these squares and rectangles that are used to detect features.
Next, we have the behavior module. This starts off with the facial recognition sensor and is paired with the Raspberry Pi board. That reads the data points off the user's face, and that moves to the database. And then from the database, that processes the information and stores it. Then moving to the web application, which retrieves and sends information from the database and then is displayed to the monitor. Then we have the functional decomposition, starting off at level 0, which is the base, and that consists of the facial recognition sensor. As you can see, the input is the facial data, and the output is the reading of the data points on the user's face to send to the database. And then next we have level 1, which is the overall system decomposition. You can see in the box, we have a system consisting of the facial recognition sensor and how it works. First, the individual must initialize their face with the initialize the sensor with their face, and then it sends a voltage signal to power the source and activate the facial recognition sensor. And that sensor will approve or deny the biometric and continue to communicate with the database. The database then sends and displays the individual's account information to the monitor system. This will show the restaurant individual and the individual what kind of food that they ordered, and give the customer an option to either reorder an item from the history or order something new.
This is our hardware design implementation. The board that we went with for this project is a Raspberry Pi 3B. As can be seen here, as a quad-core processor rated at 1.2 gigahertz and 1 gigabyte of RAM. And to store everything, we used a micro SD card, which was on the Raspberry Pi 3 board. And this is the board that we use for the project. We both use the case, and this is what was inside the case. The 4 plugs that we had in there were mouse and keyboard for being able to input, and the HDMI to output to a screen, and the power supply to power it. And we went with the Raspberry Pi V2 camera. This is the hardware demonstration that we're going to be showing. So I'm going to be showing the camera at first, and then the camera is going to be scanning my face, and then it's going to be training the data and being able to detect my face and output it to a text file. Right there is the it taking pictures of my face and then storing it in a folder. This is the data being trained. And this should be able to recognize the user. And as you can see, it's small, but my name is above the square. And this is the output of the text file with my name on it. So we decided to use the Raspberry Pi 3B because it's easy access of being able to work with OpenCV, and it's very user-friendly GUI, and it fit very well within our budget. We also use the Raspberry Pi V2 camera because it has a great ability to capture high-quality images at a very relatively fair price. We also use the Raspberry Pi case because it's a sleek design that would look good to users, and its ability to keep the camera in place so it can be easier for users to work with.
This is our software design. The video on the left shows us creating the database originally. If we can see here. That's right there. And then the video on the right shows us importing images into the database with numbers and text info. So for our database, we ended up using SQLite. This is due to SQLite being file-based. The database consists of like a single file on the disk, which makes it extremely portable and reliable. It's also a little simpler because none of us had too much experience with SQL up to this point. OpenCV is the most popular library for computer vision. So for our facial recognition system, that's what we decided to use because there's just so much out there. And then in addition to this, we use Python for the code due to the number of resources with OpenCV available.
For our survey and questions, we distributed a survey to roughly 40 people. We were actually surprised to see that 50% of the people said that they were uncomfortable with the restaurant using the facial recognition software on them. So we took this into consideration in order to find different ways to assuage these worries and ensure that the customer knows that their information is safe and not being shared elsewhere. That would also have to be advertised before signing any type of consent form in order for the restaurant to be able to track the individual's past orders history and have their account on file. Here is just some of the dietary restrictions and food allergies that we found, and we saw that the majority didn't have any allergies or restrictions, but the remaining 40% did, which is still important to take into consideration for the restaurants to know. And then the next slide, again, here we see that the majority don't have allergies, but 30% said they did, which is still important to take into consideration and add their particular preferences into their account so that restaurants will note that. And then in the next slide, although most people did not have allergies, we found that roughly 80% said that it was important to take these restrictions into account before sitting down at a restaurant.
So as for our testing results and analysis, for the database, we were able to properly compile and store the information, and we were able to have the database communicate with Python code. It was also able to store integer, text, and picture data, which was all the type of data that we would need for this project. And the imaging sensor was able to take high-res images and videos, so it can work with the algorithm that we used. And the Raspberry Pi board was able to work with the image sensor and output users that were detected to a text file. It still needs some work on sending information to the database. And as for the face recognition algorithm, it was able to accurately capture data and store it. So as for our unit test, we tested to see if Python code was able to work with the SQLite database and the MySQL database, and it was able to properly and quickly send, and we were able to check that information quickly. As for the integration testing, we were able to see if the board would be able to run MySQL and SQLite on the board, and that was successful. We were able to have the database and be able to see it for MySQL and SQLite, and we decided to go with SQLite because it was easier to work with at the time, and this is the point where we tried to port the SQLite with the live data algorithm that we were using, and the test that we had on it, like running the code to see if there will be a proper output and to check to see if it will work with live data was being entered. and to test to see if the board quickly enters the data into the database. They all failed because we ran into some issues, which we'll discuss a little bit later. This is just the iteration table for all the testing that we did for this project. And so as for the error that I was referring to, the board, I would say about halfway into the semester, stopped displaying completely. So I went through some steps when I was at home to be able, as well as some members of my group, to be able to fix this error. So the board was not displaying properly, and I first attempted to restart the hard drive, and then I realized that it was the board HDMI output that was the issue, and so I had to replace the board and then and then I had to install OpenCV and the OS back on it, and that was giving me certain issues that took a very long time to be able to fix. And also the code was giving me problems with the different file layout that I had on the new install.
So for the design and implementation change, obviously it was very hard when we switched to remote classes for everybody to kind of adjust. And this affected our group as well. All of our hardware had already been completed, but our HDMI port breaking on the board led to problems. So that took time to order a new one, and that was also delayed due to everything that's going on. Software, though, was really the main focus at this point, and it was easy to kind of communicate with each other after doing research and sending ideas to each other back and forth. But the change was definitely very hard to adjust to. But as a group, we were able to overcome it to a certain point.
As for the project go, no go milestone, we were able to have the board at basic communication with the database, but that was not able to get completed. We were also able to get a case for it so it can have a nice aesthetic design. But we were not able to, we plan on creating a button so that the users can press it for new users and existing users. We were not able to get to that due to the technical errors that we were having. And we were also going to, time permitting, work on database security and customer data analytics, but due to all the errors, we weren't even able to get to that. And we weren't really able to put everything together at the end of the project because of all the errors. This is our cost analysis. We had to buy 2 Raspberry Pi boards because one of them broke. This was the Raspberry Pi camera module. We also had to get a micro SD to be able to store the OS and data on the Raspberry Pi board. And this was the case that we purchased.
At the end of the day, we were able to accomplish a lot of the goals we set forth earlier in the fall semester. We didn't know what we were going to do at first. We all wanted to be on the same page and do something we were interested in. So after we finally figured out what we wanted to do, we just kind of kept rolling with it. Obviously, with everything going on, it was hard to kind of adjust, as mentioned before, especially with some of the technical difficulties we encountered. But it was definitely a great experience overall to kind of work in this group and work on this project.
For new features to add to future work after survey, we asked people in the survey that we provided which features they might add on to the individual's preference. And some of the many answers that we got were circular tables as opposed to rectangular ones, seating at a particular section, the food coming out at a rapid pace or a certain time, the atmosphere, games, entertainment, or a button to get the waiter or waitress's attention. These are all really great features and preferences that we could have taken into account and added into our final project if we had more time.
These are just some of the IEEE standards that we used during it. We had IEEE 730, 829, and 1008.
As for the ethics issues considered, the biggest issue that a project like this will run into is a user not being comfortable with having their face scanned when they enter a restaurant. As you saw in the survey, half of the people weren't open to that idea. But I think with a guarantee of data security, and I think that users would be more open to this idea, as well as having the users like completely consent to this idea and make it completely optional for the restaurant experience. I think with both of those things in mind, I think it would definitely attract more potential users. And these are our references. Any questions?
Not a question, but just going to comment. I think this might be a nice project, type of a project to collaborate with maybe a business team on. It just seems like there's a lot here besides the technical part, which you guys seem to do very well.
Thank you.
Thank you.
Thank you.
Very good project and well defined, and based on the resources and the circumstances that we had, this is a good project. Okay, guys?
Thank
Thank you,
you.
Dr.
So
Yakos.
continue your hard work.
Thank you.
Thank
Thanks.
you.
Thank you,
Give
Ina.
the guidelines. Set the guidelines to everybody. 5 things to be done, to be added in your final report. Your final report has to be high quality. If it's not high quality, it's going to affect your final grades, just to let you know. Okay, please be careful to write good quality reports. This is an area that we're lacking and we need improvement. Okay, guys? Thank you very much. Thank you.
Thank you, Dr.
Thanks.
Yakos.
Thank you. Thank you.
Hello again. I would like to introduce my next team, Michael, Jack, Ostrich, and they are presenting the autonomous navigation using centralized intelligence. So the mic is yours. Please start presenting.